Alrighty, in today's video, we're going to be talking about section 3.3, linear equations in two variables. Simply just means we just have an x and a y. So a standard form equation is what we call ax plus by equals c, meaning the x and the y are on the same side. Let's see. We also have x-intercepts. Which are written as some value, comma, 0. And then we have y-intercepts, which are some number, comma, b. That's pretty much it. So basically, we're just going to be looking at some graphs, finding the x and y intercept, and of course, there's always those good old word problems. So let's get right into it. All right, so the first problem we're going to look at is number 4. This is now on page 179. So 4 states 3x plus xy equals 2y. And you're just asked to determine if the following equations are linear. So if you can get it in the form of what I like to call y equals mx plus b, but if you can isolate y by itself and x is in there, then you pretty much have a linear equation. The issue here, just to kind of save yourself some time, anytime you have an x and a y next to each other, I would really like to say always, but let's go ahead and just work it out because there is always that one case. So what we're trying to do is get y by itself and make sure that x is somewhat in this form, or it can be written in this form. It might be a 0x, but it can be written in this form. All right, so the first thing I'm going to do is actually subtract the xy. So I want all my y's on one side. So I get 2y minus 2x. Nope, not 2x. 2y minus xy. And then I'm going to factor out this y. When I do this, I would be left with a 2 minus x. I now have one single x I can deal with. Then to get rid of it, I'm going to divide by 2 minus x. And I now have y by itself. But notice I have multiple x's, and then I also have a fraction going on. This is actually called a rational equation. So there, I can then say no. Again, I would love to just state that if you have an XY situation, the answer is always going to be no. But there's going to be that one case. And I can think of one in my head right now. If you have like XY plus 2XY, oh no, that would be different. Let's see. Here we go. You have a x squared plus xy equals xy. So if you divide everything by x, you then have x plus y equals x, and then you would subtract x, so then y would equal 0, and now you have a linear function. So there is situations out there, but I almost want to go 90% time. You see an xy, it's going to be no for the linear. All right, let's look at another one. X minus y over 2 plus 7 over y over 3 equals 5. All right, so again, the concept is to try to get y by itself. So here we go. So we get, I'm going to simplify this by saying 1. Actually, let's say we don't like fractions. Oh, by the way, this is number 6. Sorry. Let's say we don't like fractions. So I'm going to do what I did in chapter 2 and get rid of the fractions. So my least common denominator between 2 and 3 is actually 6. 2 and 3 can both go into 6. And when I do that, I then can multiply this by 3, multiply this by 2, and then this would actually get multiplied by 6. So I now get 3x minus y plus 14. Now I'll just write it out so y'all can see it. 2 times 7y equals 5 times 6. So distribute. So this is 3x minus 3y plus 14y equals 30. Combine like terms, I get 3x plus 11y equals 30. And then now I can see that I can subtract the 3x. So I get 11y equals negative 3x plus 30. And then I can divide each term by 11, giving me something that looks like this. So even though they're not perfect numbers, it does give me that mx plus b that I need. So this would be a yes. All right, let's look at another one. Let's look at number 7. 7, you're given 6 over x minus 5 over y equals 2. Again, I don't like fractions, so I'm going to multiply by the least common denominator, which in this case is x, y. When I do that, I will be multiplying this by y, multiplying this one by x, and then this one will be getting xy. So this is now 6y minus 5x equals 2xy. And so kind of looking at this, I can do what I did earlier, in which I can move the 6y over, factor out the y, and divide it. But because I can see that there's no way to cancel at this moment, I can now say no. Because I did one similar to this, and there was no way for me to do this. If you would like to see more of a proof, then if you're not convinced, take it a little bit further. I'll factor out that y now, so I get the negative 6 plus 2x. But the moment I do this, that is where it fails. So if you can realize it here, if not, you can go all the way and you'll still get no. All right, let's do another one. Let's look at 13. I get x times y plus 1 equals 16 minus y times 1 minus x. So I distribute. So it gives me xy plus x equals 16. Distribute gives me minus y plus xy. So this is why you can't assume if there's an xy on it, it's automatically going to be a no, because if I subtract xy on both sides, notice they cancel each other out. So now I have an x equals 16 minus y. I'll subtract 16 because again, I'm trying to isolate my y. So this is x minus 16 equals negative y. If negative y equals this, then that means that negative x plus 16 would equal positive y by simply multiplying everything by negative 1. So I do get that mx plus b formatted that I want. So this is a yes. So I could not assume here because I got to combine like terms first. Right, so that's a good example of one, not to assume if you have an xy, it's automatically going to be a no. All right, so let's look at different types of problems. So let's look at number 25. In this set, we're asked to find the x and y intercepts of the given equation and then sketch the graph if possible. All right, so we have 4x minus 3y equals 12. To find the x-intercept, let y equal 0. So in this case, it's 4x minus 3 times 0 equals 12. That zeroes out, so I'm going to divide by 4. So x equals 3, kind of similar to what we did in section 3.1. So therefore, my coordinate here would be 3, 0. Same concept with the y-intercept, but this time let x equal 0. So now it's going to be 4 times 0 minus 3y equals 12. That zeroes out, divide by negative 3. So y equals negative 4. So in this case, 0, negative 4. All right, so that's how you find the x and y-intercept. Pretty simple. Now just to graph it. So 1, 2, 3, and then 1, 2, 3, 4. So again, notice the x-intercept crosses the x-axis, the y-intercept crosses the y-axis. Once you have your 2 points, do your best job of sketching that like that. There you go. So let's do some more. Let's look at number 26. 26 says y minus 3x equals 9. So again, looking for my x-intercept. I'm going to let y equal 0. So it's going to be 0 minus 3x equals 9. That goes away, so I'm just going to divide by negative 3. So x equals -3. So my x coordinate here is -3, comma 0. Find the y-intercept by simply saying x equals 0. And then I would have y minus 3 times 0 equals 9. That would zero out. So I'm just left with 9. So therefore, I graph it. So again, this would be 0, comma 9. I would have 1 at 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. And then do your best sketch. All right. Let's look at some different looking ones. So let's look at number 29. It says 3y equals 9. All right. To find my x-intercept, I let y equal 0. So in this case, this would be 3, 0 equals 9. So this is 0 equals 9. So when you get an untrue statement, there is no x-intercept. So try my y-intercept. This time I'm going to let x equals 0. And so this is now 3y equals 9. So y equals 3. So my x-intercept here must be 0 equals 3. So I graph it over here. I go to 1, I go 1, 2, 3 here. There's my 0, comma 3. And when it's written like this and no x-intercept, you just have a horizontal line. So it does not cross the x-axis. It will only cross the y-axis. All right, let's look at some more. Let's look at 31. 31 is x plus 2y equals 7. Same process, x-intercept, y equals 0. X plus 2 times 0 equals 7. That zeroes out, so x equals 7. Y-intercept, let x equals 0. So now this is 0 plus 2y equals 7. 0 cancels out, so divide by 2. So y equals 7/2. Again, the x-intercept here would be 7, comma 0. This would be 0, comma 7/2. Graph it at your best ability. So 1, 2, 3, 4, 5, 6, 7. 0 and 7/2 would be about 3.5. So 1, 2, 3, 4. So it'd be about right there. And then you just kind of sketch it. Pretty straightforward. Let's just do one more to make sure you got it. Let's look at number 33. Y equals -x. X-intercept, y equals 0. So that means 0 equals -x. If -x equals 0, that means positive x will equal 0. So in this case, 0, comma 0 is my x-intercept. Y-intercept, let x equal 0. This would be y equals -0. So y equals 0. So my y-intercept is 0, 0. Typically, if you don't have anything adding or subtracting, your intercept is going to be 0, 0. And it's both an x-intercept and a y-intercept. So you only have 1 point. Next thing you need to know is that y equals -x is the negative parent function. And it looks like this. Just an FY with the slope, you would just go down 1 over 1, down 1 over 1, and so on to make more points. All right, so let's look at just graphing in general. So let's look at number 40. This is y equals 2x plus 3. You're asked to graph. So the best way to graph something like this is you start at the y-intercept. Again, y equals mx plus b. This right here is the y-intercept. This is the slope. So I'm going to start at my y-intercept, which is at 3. So 1, 2, 3. And then my slope is rise over run. So m is rise over run. So this 2, I can put it over 1 to make it a fraction. So I need a rise 2, run 1. Once you have 2 points, that's all you need to graph. All right, let's look at another one. Let's look at 42. 2x minus 1 equals 5. In this case, I would just solve for x because it's not in the correct formatting. So I get 2x equals 6, divide by 2, so x equals 3. So earlier when we got y equals a number, it's just a horizontal line. If you get x equals a number, it is a vertical line. And there you go. All righty, so there's one more. It's a word problem. So let's look at number 50. Number 50 says the lowest point in the ocean, the bottom of the Marina Trench, is about 1,100 feet. Deeper then 26 times the lowest point. So 1,100 feet deeper than, so that's going to be plus 26 times the lowest point. Find an equation to express the depth of the marina trench M in terms of the depth of the Dead Sea. So the Dead Sea was represented by a D. Erase these feet here. So you got 1,100 plus 26D, and then that would just be M. Yep. So we did that. So that's it. So it's 1,100. Deeper than means to add. 26 times means to multiply. And it told us that the Dead Sea represented by D. And this will tell me what my depth of the marina trench is, what they told us to let be M. So that was first part. So let me put an A there. The next part is then says, then solve the equation for D to find the depth of the Dead Sea in terms of the trench. So it's going to be a literal equation. So that means that what a literal equation just means I'm going to get equation back out of it. So here's my equation. First thing I'm going to do is subtract 1,100, get rid of those constants. So I get M minus 1,100 equals 26D, and then divide by 26. So then my D would equal M minus 1,100 over 26 in terms of M. And then the question at the very end, I guess you could say part C, are these equations linear? This is mx plus b. This can technically be rewritten as 1/26m minus 1,100 over 26 equals d. So yes, this is still mx plus b. So yes, they can both be written as a linear equation. All right, and that's pretty much 3.3. So as always, if you need more examples, just let me know. Other than that, I will see you in the next video. Bye for now.